Hi, hello everyone. Welcome to our webinar session today. It's called Passive Optical LAN 103, a deep dive into physical aspects of passive optical LAN deployments. It's brought to you by the Association for Passive Optical LAN. My name is Jeff Burke. I am an AppLAN Marketing Committee member, and my day job is I'm the Chief Marketing Officer at DZS, which is a company which is one of the founders of AppLAN and a platinum AppLAN member. I'll be the moderator for this 1 hour session. Before we begin, let me explain what AppLAN is. Basically, it's the Association for Passive Optical LAN is a non-profit organization tasked with advocating for the global adoption of passive optical LAN local area networks. And basically, each of the companies involved today is a member and an evangelist of PON technology, and of course, the key advantages that make passive optical LAN an ideal solution for deploying networks in enterprises. We're excited to have you join us today for what is really the 5th in a series of webinars that we've been having over the course of the late summer and this early fall, and been focused on the hottest topics in the field of passive optical LAN technology. I heard there may have been a little bit of a mix-up this morning and some email notices sent out reminding you of the session, so we apologize for any confusion and applaud you for making it to here for the session today on time. Over the last 5 months, we at AppLAN have been alternating between market-focused and technology-focused events, and this month we are back in the technology focus for this Passive Optical LAN 103 deep dive into the physical aspects of POL and deployments. These technology sessions echo the components of a 2-day training event that we offer at Bixie events around the world, but with the deeper dive and some up-to-date reflection of what's actually going on in the current market. So with that, let me introduce you to some of the folks that are on the call today. We have, as I introduced myself as moderator, but we also have Ron Tellis. He's the Technology and Applications Manager for LAN at Belden. Ron, I don't know if you want to take a second to say anything about who Belden is and what their place is in the industry.
Yeah, Belden is a manufacturer mainly of cable, but we have a lot of different other companies under our umbrella that help support all network connectivity for all the infrastructure needs, from industrial to smart buildings and so forth. So that's in a nutshell, that's who we are.
Fantastic. Well, also joining us today is Jeremy Kendall. Jeremy is the CEO and Systems and Infrastructure Engineer at Edge Power Solutions. Jeremy, why don't you give us a bit of insight into what Edge Power does?
Edge Power is a manufacturer of what we call approachable remote power solutions for the telecommunications industry, remotely powering optical LAN devices, other telecommunications devices. And the reason we say approachable is we try to make it a plug-and-play solution, not requiring specialized training or electricians and things like that to do the install.
Great, thank you. And our last panelist today is Steve Lindberg. Steve is a colleague of mine at DZS, system engineer. He's also a technology committee member at AppLAN. And Steve, you've been working in passive optical LAN now for a number of years. I don't know if there's anything you want to share with regard to your background.
Not much. It's been about 13 years, Jeff, and I was a support guy before I was in system engineering.
Perfect. Well, I think we have a great lineup today with regard to the overall agenda. You know, we've gone through the introductions now. Really, what we're going to do is we've split this up into 3 discrete sections where we're going to be, not only talking about the critical pieces of any successful passive optical LAN deployment, right, but also really some of the things that we've also learned from real live deployments and the best practices over the course of this time. So with that said, I believe I'm going to hand it off to you first, Steve, to kind of kick us off with regard to just some of the basics of the network before we get into some of the details.
Yes, sir. The slide we're looking at, a lot of you have seen many times before. Most folks are familiar with optical LAN terminal, which is basically on head-end device. The passive component and the name comes from the splitters and the single mode fiber structure in between the OLT and the ONTs. sure most of you guys are familiar with that, but we'll talk a little bit more. And the power components, we're going to have Jeremy here to expand on that. ONTs and OLTs must be powered. Now, with most of the vendors, you can either DC or AC power. DC power to the ONTs, at least, is becoming a lot more common. Jeremy will delve into some of the reasons why that is. Next slide, Jeff. Thank you. So one thing that I really want to stress on this call, the inherent nature of flexibility in design for GPON networks or next-gen PON networks for any passive optical LAN network. So many reasons for that, but we'll start on the OLT side. So most of the vendors, again, we have anywhere from a 1U chassis, pizza box style chassis, up to modular chassis where you have slots to put any number of line cards you need for the number of OLT ports you may need. Uplink cards, or sometimes there'll be fabric cards that provide the core connectivity, management, your database, those kind of things can be redundant. The note here on typically 1 or 2 OLT shells being required for a project, that's a critical idea. So, no matter what the size of the project is in the enterprise world, from a small hotel, a school, up to, a large stadium, large business complex, typically you only need 1 OLT chassis. That's because the density of these chassis can be huge. We could be talking, anywhere from a few hundred ONTs or a few dozens of ONTs up to tens of thousands of ONTs, all served from a single OLT chassis. So for that reason, it becomes very critical that you understand your redundancy options, for one. Usually you'll have some type of a power redundancy to the chassis. Secondarily, even with the 1U chassis, you'll usually have more than one link up to your core network. So if an SFP fails or a link goes down on the far end, you'll continue to run. And in addition to that, GPON and the next-gen PON technologies give you a built-in additional type of redundancy, which is described in the bottom right of the slide here, where you can run 2 single-mode fiber connections to a splitter instead of 1, and potentially run a separate conduit path. And in that case, you have fiber cut protection all the way to splitter. And we'll talk about splitter placement and that kind of stuff a little bit more. But what that means is, typically you're trying to push that splitter as far out as you can to minimize the amount of material and labor involved. So you will get, with the redundancy, that fiber cut protection pretty far out to your end users. So it's an option. It's a very useful option. The one thing that I'll add here that we haven't included is most of these ONTs also allow for subtending. So keep that in mind. A lot of projects, I don't think we remember that that's available. So in other words, I can have a master chassis that is feeding a secondary chassis, maybe to another building, another part of the property that provides data connectivity to that secondary chassis. And it can be, a 1 gig link or a 10 gig link or larger than that if required. So again, I'm going to try and focus on the flexibility inherent to a PON network. So forgive the cable dressing here is not real pretty, but forgive that in the picture. Does give you a really good idea of what really surprises folks who are used to a copper network, traditional copper network, and visit a PON installation. So you're used to seeing these dozens and dozens of copper cables, Cat5, Cat6 cables, heavy duty cable trays, the kind of mess that you see here on the top side. Potentially all of that goes away. And if you see on the very bottom there, this is an example of a 1U OLT. And you do see 4 copper cables going in there, but that's the core connectivity to the box. And on the very bottom right, you see just a little bit of single mode fiber strands. And that's what's feeding out to the ONTs and meeting the needs of the end users. So it just gives you a pretty good idea of visually the kind of differences we're talking about. Now, this slide, very similar, a little bit larger chassis. but does show you that with a huge increase of users, this 3U OLT here is serving, looks like 16 OLT ports, whereas the last one was just 1 or 2. And you can see it's still a very small footprint in the rack. Now again, I was an old guy that used to do the cable dressing, so forgive us. But in the center there, you see a 24-port ONT, and again, back to the flexibility. You can have an ONT sitting next to your OLT chassis, like in this example, if you have a need for, you know, Ethernet ports in that same room. So, you know, 24-port ONTs are common now. 1 port, 4 port, 8 port, basically anything you need, and can be physically located pretty much anywhere you can dream up. So one really cool example, and there are others out there that are this large, but this just really showcases all of the different technologies that can run on a PON. So the Mercedes-Benz Stadium, Atlanta Falcons NFL Stadium, everything you see here is running on the PON network. So you can see that the amount of sheer fiber optic that you're talking about, 6,200 kilometers. You know, think about if it were copper, it'd be, you know, orders of magnitude more, you know, more cost, more labor. The core network, again, for the IT folks out there, with a PON network, you don't lose control of those core network devices. None of that goes away. We just allow connectivity between those core network devices and the Ethernet ports on the ONTs, extend that with a very high speed, you know, layer 2 network, typically on single mode fiber infrastructure. And, you know, you still control those endpoints. You still control all of the upstream hidden devices and core switches, as you see a big Cisco Nexus switcher router out there, a couple of them. And DAS, they also run a DAS overlay there. They have many, many Wi-Fi access points, IPTV, CCTV cameras, basically the whole gamut here. So really goes to show you that you don't have to limit yourself and wonder, you know, is the technology I want to run on the PON going to actually work or not? This stuff is well soaked and proven in the field. Again, an idea of how small the footprint can be of the PON, even in a large installation like this. So they have 3 racks here, and I've got pictures of the whole rack, and honestly, most of the top there is not used, available for future use. But the chassis themselves, they've got 4 redundancy. They've got 3 different chassis, several different core providers, and you know, each of those chassis is only using up 14U. We're not talking dozens and dozens of racks. Now they do have many other racks out there for other equipment, but the PON itself requires very little footprint. And again, a very small amount of single mode fiber as compared to what the copper requirement would be.
Well, thank you, Steve. I know that Ron is actually going to, from Belden's going to step in and walk us through the next segment of splitters and fibers. I did want to let folks know that there are is a Q&A session at the bottom of your, or as part of your overall interface with us. So if you have questions and things, please why don't you throw those in there. We'll either answer back to you directly, or we'll answer some of these at the end of the session. So with that, why don't you go ahead, Ron, and kind of walk us through the next segment here.
All right, thank you very much. And first up, I'd like to just thank the FLN organization for inviting me to present. This is quite the honor. What I am going to discuss is what many people call the optical distribution network. It's the infrastructure that gets the signaling from the OLT to the ONTs and vice versa. So it's kind of outlined here as a splitter, but we're also going to talk about the fiber that connects these devices as well. Next slide. So different kind of fibers, there's many different types. The most popular ones are single mode, which are usually which are yellow for the indoor versions, and then there's also multi-mode, which ONT4 is what we call Erica Violet. This is unique to Belden, and it's slowly being accepted throughout the industry because within the standards, the ONT3 was Aqua, and then they came out with ONT4, and it was also Aqua. So we wanted to come up with a way to distinguish between the two. So that's why you might see OM4 Erica Violet or maybe Aqua, but to help things out when you mix different cabling types. That's why we went that route. These cables are usually widely used for distribution cabling. Distribution cabling means that there's many fibers in there. It's got the yarn in there so it can be pulled, and it's meant to be distributed throughout the building. And then the other types are drop cabling. This here is a drop cable it's black. It's indoor outdoor. It's staple mounting resistant, meaning that it has enough crush strength or ability to handle the staples to staple to the wall. It has 1 or 2 fibers. It's not ideal for pulling. When you have 2 fibers, it's better than when it has 1 fiber. But it can be if we use similar type of pull strings that we do with category cabling. And these are ideal for going from the splitter to the ONT and some of the different topologies that we're going to talk about where we might have the splitter out closer to the end devices. And then the other one is a hybrid cabling. And hybrid means that we have fiber and we have electrical conductors inside. And this definition has been kind of muddled about a bit. Some people call it composite, some people call it hybrid. And I just want to say that we took steps in the standards for TIA and ICEA, and we're also working on an NFPA to combine and zoom in on one definition. That is, a hybrid cabling is fiber with electrical conductors. And so that's the case where we want to deliver power and data over long distances. And we can do that with a class 2 type of power device or other power devices that are out there. Again, these would have similar fiber as you see in the distribution cabling, but it has the addition of copper conductors and power as well. Okay, next slide. And then at the end of these cables, we obviously have to connectorize them somehow. There's one way to do it is splice on connectors, which I don't have shown here, but they act very similarly, where they're spliced on and they exhibit the low electrical insertion loss performance, electrical performance that you see here posted for our pigtails as well. So we can have pigtails that are for a single type of or dual type of connections that you see here, or we could have multiple pigtails that can go into a cassette. And then I also show different cable types and different connector types that can go onto these things. And when we talk about splicing on connectors or pigtails, that's where we get the best benefit from our loss budget when we have to calculate that. Next slide. So we also have the pre-term solutions, and I tried to demonstrate that through our smart part numbering system that we have for our patch ports. We can extend this to different cable types as well, but I just thought I'd let you know that maybe you're always dealing with SC APC, but there's also LC duplex, there's simplex, there's APC, non-APC, and so forth. So there's all these different variables out there, and there's also different fiber types, OM4 and OS2 being the most popular, and then obviously the link can also be there. So it becomes important to be able to have the versatility to select what's needed so that your cassettes and your cables and your connectors and your splitters can all be connected properly, and also be able to allow for moves, adds, and changes in the future. Next slide. So let's look at one of the most popular ways to deploy a splitter, and that is where we have one splitter for the whole network. This most common is a 32-port splitter where you have one or two fibers coming into the splitter, and then it splits out to 32 different end locations. And these end locations are where the ONTs are, and then from the ONTs, depending on the type and number of ports and so forth, would determine how many end devices that you would have connected. Next slide. Okay, and so here's another example of what could happen with splitters, and this is more of an engineered cascaded splits. And the reason I say that it's engineered is because going through a splitter adds loss, right? So if I'm going through a 32-port splitter, I'm going to exhibit over 17 dB of loss of my signal going through that splitter, and that's because we're taking one path and then going 32 different directions. So it's obvious that we're going to have some power loss at each one of the ports. But we can also have an engineered split. Let's say I have my locations that are very close to my central office or my service provider. I might have splits that are heavier in density, like let's say 8 or 16 ports. And then if I'm going further away from that location from my service provider, I might want to consider having fewer splits, let's say, so that I can maintain more power and not have it lost in the splitters, so that I can maximize my reach. Obviously, this takes a little bit of calculations and know-how, and that's why it's called an engineered split. And you have to really kind of consider the different losses that are going to, as you go through the different splits. Next slide, please. So we're going to talk about 3 different types of splits, and the first one here is what we call the centralized split. So I have one location. My one location here is the IDF, the intermediate distribution frame. So this is where let's say the riser comes into a particular floor here, and then goes horizontal. Since I only have one location for my splitters, I have to have several cables going out, several fibers going out to different areas, and these areas are called consolidation points. As you see on the right on the bottom there. So my consolidation point is a location where my distribution cabling would come into some type of, probably a cassette, and then going from that cassette out to my end devices, which are the red dots, which would be my ONTs. This particular type of deployment maximizes the ROI, has lowest labor and so forth, but it does have some drawback. So there's another different way of breaking things up into zones, as you see here, but then also adding another layer of security. So if you go to the next slide. And that's what we're going to call the zone split. So here I'm bringing my fiber locations, my FSBs, and my fiber splitter boxes. I'll break up my areas into zones, and within these zones I'm going to have the splitter box. And then at that splitter box, I'm going to go from the splitter box to all my end devices. Now, the benefit of doing something like this is that this adds a level of protection over a certain area, right? So if I was to have some issue that would happen, either at the OLT or something with the cabling or the fiber that came to the FSB, I would build in some type of redundancy, either to an additional port at the OLT, or let's say a different path with the distribution fiber. So instead of having the one line that you see here going straight to the IDF, maybe I have one path going clockwise and another path going counterclockwise through the location, so that I have a level of redundancy within the same network, just to make sure that those zones are always serviced. This type of protection is commonly referred to as Type B, which is the most widely deployed type of architecture or zone architecture that's used for the zone split. And you see there, I have my zone splitter in the ceiling, which houses my cassettes and my splitters, and then from that the distribution cords come in, and then my drop cords or patch cords can go out from that. Next slide. The next one here is a rack split. So what that means is I'm splitting at the rack. So in the IDF, I have a rack. So before we showed boxes or housings that could fit in the wall or in the ceiling, here I'm actually going to have a space, let's call it a telecom room, where I have a rack and I have my equipment, and right at that equipment I'm going to split out. Why would I want to do that? Well, let's have a large area that we're trying to cover. Another good example would be like a warehouse, right? So you just want to come into one location where the offices are and then split out to all these other locations and not have to go around the rest of the office or floor to service these different locations. So I have a IDF, which is telecom room with a rack in there, and then within that rack I actually put my splitters. So I would go from my OLT to some type up to my splitters, let's say. My splitters up to my cassettes, and then the back end of my cassettes would house would be where all the cabling goes out to all the different locations of my ONTs, which are the red dots, as you see here. And really this would also encourage the use of what we call home runs, where you have one cable from one location all the way out to the other location here. So just another terminology you might run across. So all these different examples, even though we showed them within a building, they can be scaled to support a whole entire campus, right? So if the red square at the bottom is my MDF, so that's my main distribution frame. And then I can go from that to different buildings, and within each building, I have my fiber distribution hubs. Add some layer of redundancy to go different directions, so that I have some protection there if needed, depending on the design. And I can scale all the concepts that we just talked about, not only within a building, but within many buildings or on the campus, as you see here. So let's talk a little bit about enclosures. And the reason I have this here is, we have to have something to house the connections and protect them. And we've talked about how we can hide these in the ceiling. And when we start putting things in the ceiling, we got to be mindful of fire ratings as well. So fire rating for air spaces requires plenum. Plenum means that if the materials in there self-extinguish, they won't reignite, and they have a lower smoke than traditional materials. The reason we want that is because as many air spaces up above the raised ceilings are the air space, I should say, and if we ever had any issue, you don't want all those toxic fumes and smoke and reigniting fires and such going into the ceiling. So for that reason, if you're going to put these devices and zip tie them to the structure up in the ceiling, you got to consider the connectivity. They have a plenum rating, which is UL 2043, just like we have to have that rating on our cable, which is CMP. Okay, next slide. So one of the beauties of PON, the Passive Optical LAN, is that I can pretty much put a telecom room, an IDF, however you want to call it, anywhere, right? So I have this beautiful hallway that I guess would be going down, but they'd be totally oblivious to the fact that that there's a panel to the left here that houses my whole telecom room, and within that, and I say telecom room kind of loosely because that's what our traditional thought process is, where we house all this traditional switches and copper panels and all that sort of thing. Whereas here, we can essentially put it into a wall mount box, and we have distribution cable coming in, goes into a cassette, patch cord over to my splitter, and then going out to the individual locations. Could be individual rooms or group of rooms in this example, and a very nice way to offer all the different network connectivity that we've come accustomed to without having to take up a lot of retail space. Next slide. Just like within the like a hotel in the last one, this one's an industrial space, right? So again, since I can have very few components, it's not requiring power. It's just needs some place to be placed so that nobody messes with it. And so you see here an example where a splitter is connected to my cable raceway over here on the left, and it's just tie wrapped up to the ladder, as you can see. So again, I can add all the network functionality without having to use up a lot of real estate and power up a lot of devices. Next slide. And that's my part of the presentation. I'll stick around for questions and answers at the end. So thank you.
Yeah, thank you very much, Ron. That was fantastic walkthrough there. So I'm going to invite Steve Lindberg back on. He's going to walk us through some of the considerations for ONT placement and best practices for the next few minutes. So Steve, you back on?
Yep, I'm here. Thank you, Jeff, and thank you,
Great.
Ron. Okay, so again, I really do want to stress on the ONT side, even more so than the OLT, the flexibility that you're allowed in these types of, in any type of a PON network. So go ahead to the next slide. This is just kind of the same general outline. ONT models. So all of us different vendors out there for the active components, we have many different form factors, many different feature sets for ONTs depending on what you're trying to do. However, at their most basic, we're talking some number of Ethernet ports. Today, most commonly, usually a gig Ethernet port or many. And usually in the passive optical LAN world, some amount of PoE wattage that you are pushing out from the ONT to your endpoint devices, right? If you're needing to power an ONT, which obviously you're going to via DC or AC power, you don't want to have to individually power all the other devices that hook up to it. Right, so in the carrier world, you really don't see PoE power on these ONTs. In the PON world, you almost always do. Now, there are a lot of other optional features like coax, where you can run RF overlay, which is a little bit out of the scope of this presentation, but you can run analog video that way. Wi-Fi, there are ONTs with integrated Wi-Fi as an option. Many times, you know, in reality, the ONTs will feed an external AP that's you know, a little bit of a more heavy-duty solution with a Wi-Fi controller. And again, the flexibility in where you put these ONTs is really the beauty of the installation on the ONT side. So I know we don't want to run out of our hour here, and I'm going to show you several different slides that kind of give you an example of the varying ways to install these things. Go ahead, Jeff. Oh, and again here, talking about less common ONTs, but also adding to the flexibility and depending on what you're trying to do. In-wall ONTs, in furniture ONTs, if you still need the RJ45 jacks that are becoming less common, there are cases where that still makes a lot of sense. Rack mount units where you have very high Ethernet port density requirements, right? If you've got a data center or a lot of connectivity requirements in an MDF, for instance, and industrial and outdoor. So as most of you know, in the carrier world where this stuff originated, outdoor ONTs on the side of the houses were very common. And there are still places where that makes sense in enterprise installs, especially some of the new smaller form factors like you see there on the middle bottom right, which we'll talk about a little more. So the wall outlet type ONTs, many of the furniture vendors still have you know, single gang boxes that you can mount ONTs up to very easily, right? So you'll still have your short, you know, Cat5, Cat6 cables running to the desktop or phone or whatever other stuff you've got on your desk. And it can be a kind of slick way of hiding the ONTs. So again, adding to the flexibility. Next slide. In some of the public schools, I've seen a trend, which is also something to keep in mind where it makes sense. It may look a little messy at first, seeing all these computer cables and stuff, but you see the actual ONT on the desk here. And there's one advantage of this. Single mode fiber is not the fragile glass of the old days, right? So it's just as robust, if you know, usually more robust than Cat5, Cat6 cables. So it's possible to have an ONT sitting on the desk, and I've seen school installs where the jack in the wall is actually an SC APC fiber connector. And what that means is, let's say you've got 4 walls in a room, a classroom, for instance, and all of those you know, wall jacks go to the same splitter. That allows a teacher to, let's say, move his or her desk from one side of the room to another, unplug that ONT from the wall jack, move it to another. The ONT will come back up, and because it's on the same splitter, you know, the same config will come up. And just another option, and you know, a way to look outside the box in cases where it makes sense. Wall box, wall mount, and ceiling mount ONTs, very, very common. So a nice way to kind of hide the cabling and the ONT out of the way so it's not tampered with. You can provide, as you see here, a battery backup locally or not. Usually that's done with when you're AC powering the ONTs, and Jeremy will talk about when doing DC power, the options for backing up power there. This example here is happens to be an ONT with AC Wi-Fi, 4 gig ports, 2 POTS lines, and you can see there the RJ45s for the gig ports go out to the room. So this happens to be an apartment condo unit, but we see this very commonly in the hospitality space as well. Go ahead, Jeff. Some of the very small form factor ONTs are allowing, again, another option for design, which basically entails mounting the ONT in a small 4x4 electrical box or other enclosure. And let's say that you've got a need for a camera or an AP out on a golf course or in a parking structure, somewhere where the distance is traditionally a limitation with copper. You can run, for instance, a hybrid cable that provides a single mode fiber for data connectivity and the copper pair to power the ONT, and run that 20 kilometers plus per the GPON spec and the next gen PON spec, and basically provide Wi-Fi capability or camera out in the middle of nowhere. So some new stuff coming. Hotel room closet is just kind of an example of a smaller form factor enclosure. This one is an 8-port. You can see there's a very small patch panel there where we patch out the Ethernet ports to the room. May go to the set-top box for the TV or the VoIP phones or whatever the need is. But you can see the footprint again, very small, allows a lockable cabinet, so there's no tampering. Easy way to get to equipment if you need to replace or make changes. Again, very common. Another interesting case here, you could see the actual ONTs on the right picture there, mounted on what previously was the heavy duty cable trays that no longer need all the Cat5, Cat6, but you can see they are in this case reusing some of that Cat5, Cat6 from the ONT out to, in this case, manufacturing equipment and test equipment, workstations in this manufacturer facility. But again, gives you an idea of the flexibility. This is kind of a hybrid approach where they're running single mode fiber. You can see the spool up there to the ONTs, but then running medium length Cat5, Cat6 cable out to the devices. So again, the sky's the limit as far as dreaming up a design that makes sense. This is back to the stadium we looked at there, but on the ONT side. So these large stadiums, many times what you have, you can see on the very far left picture there, and then a zoom on the middle and right, an enclosure where the ONT is actually mounted in there, very small. You can see in the middle picture at the top. Again, a hybrid cable coming into that enclosure that provides a single mode fiber and the copper pair for power in the same sheath. And this allows the ONT to power, in this case, an access point, completely sealed off. On the far right, you see the detail there. You see the SCE APC connector that goes out to the splitter. In the middle, you see the Ethernet cable that goes to the WAP and also powers the WAP. And on the right there, you see the DC power coming in to power the ONT, which again then powers the AP or any other device that you like. Okay, so this is a higher education install, ceiling closure on the right there. You can see closed up on the bottom right. It's pretty much out of the way, but still allows access for maintenance and things like that. This is a example of type B redundancy, which Ron talked about, where you are running 2 ports, usually done on 2 different line cards, out to the splitter, which again gives you protection on the fiber. If you have a fiber cut or SFP fails or connector fails, you'll continue to provide connectivity to those ONTs. And in the bottom middle there, this is more along what Jeremy will be talking about, but this is the remote power DC distribution to the ONTs. Telecom Closet here, this really is just showing, again, a hybrid approach. On the bottom there, you've got a few ONTs, not OLTs, but ONTs that are providing a whole lot of Ethernet port connectivity in that room. So again, sky's the limit, right? These 24 port ONTs, they can be sitting right next to the OLT chassis. They can be pushed out, as far to the edge as you want. As most of you are aware, distance limitations really don't exist in the enterprise world because we're talking, depending on transceivers, up to 30-something miles. So, you can put this stuff anywhere that makes sense. Now, that does sometimes allow for designs that maybe are not so great, but usually it allows you to come up with, what makes sense for your customer, and many times, ideas that are not previously available with copper network. Outdoor enclosures, these are, old school in the carrier world. They run OLT chassis in pedestals and stuff all the time, but that doesn't mean that they don't make sense for some enterprise installs as well. So many OLTs are carrier class products, so they can be mounted outdoors. They can be in a sealed off enclosure, as you see 3 different types here. The 2 on the left are actual OLT chassis, and the 1 on the right is an ONT. But in either case, outdoor enclosures is done all of the time. So again, in the interest of time, I want to make sure that Jeremy gets the time he needs here. But the ranging process in a nutshell, you basically have an ONT connected to your fiber infrastructure. It initiates a registration up to the OLT. The OLT, basically learns the capabilities of that ONT and then starts talking OMCI so that you can configure and monitor and things like that. Serial number is learned by the OLT, and you can manually assign that to the virtual port, or some of the more common methods now are let it auto assign. That serial number is right on the side of the ONT or an FSAN number. Your field tech can, read that and be sure that the ONT you're monitoring or configuring is correct. That's the basic idea. In the ranging process, there's an allocation of upstream bandwidth. It is a shared TDM technology in the upstream, although it's very high speed, and for all intents and purposes, from a user perspective, you wouldn't know. But the distance and delays taken into account between all of the ONTs, and it basically ensures that the upstream transmission of each ONT, they don't collide with each other. So in reality, this stuff used to be required knowledge, but quite honestly, in the modern world, it's usually as simple as plug an ONT in, the OLT chassis will see it, put your serial number where you want, and start configuring. On the far right there, you see the actual bread and butter here, which is VLANs, PoE wattage, your QoS, is it IPTV, IGMP aware, all of the stuff that the network guys do all the time. So this ranging process, while interesting, you don't need to be, the rocket scientist, GPON guys of old. Pretty much this is all done for you, and it's much easier to configure, let's say, than when I started doing this. Okay, I think this is the last slide here, Jeff, for me. Again, this just reiterates the need. This is very important to, as you're installing ONTs, make sure that you either barcode scan, make sure that room 101, the ONT somehow is associated with that. Now, again, you will always know which ONT is which based on a serial number. We can always cross-check that from the OLT chassis itself. But, good naming conventions, good record keeping is critical. And, it's something that, if done improperly, can make a GPON project, give it a bad name, make it not look good, and we don't want to do that. So don't forget about this. That's my last slide. Back to you, Jeff. Thank you.
All right, thank you for that walkthrough, Steve. Let me introduce Jeremy Kendall again. He's going to come in and talk to us about powering options for passive optical LAN deployments. So, Jeremy, you there?
Yes.
All right, great.
Yeah. I want to talk to you a little bit about the critical role that that power design plays in the successful deployment of an optical LAN network. I have a extensive background in optical LAN that kind of led me to be in the power world. So I go back quite a ways with optical LAN as far as an installer and engineer. So So I have different perspectives than somebody that just does just power. So, but anyway, if we can go to the next slide. When it comes to powering your ONTs, there's really two ways, and then within those two ways, some different ways of doing it. As Steve spoke about, your local AC power, usually in the form of a plug and a transformer brick of some sort. We have a traditional rectifier or rack power fed from your MDF or IDF, and then within those, there's now intelligent remote power and some combined connectivity solutions. Next slide. And as I said, when we talk about local power, we typically mean AC, and then remote power, we typically mean DC. Not always the case, but where you see those examples, like in a ceiling enclosure, we looked at it as a place you can do AC power because the cord or the wall wart is hidden, so it's not something that you would consider aesthetically not pleasing. But in some of the examples that Steve showed earlier, like in a conference room or a new office, you know, an ONT on the wall, or those wall mount ONTs are much more suited for remote power where that is hidden, so it wouldn't look nice to have that wall wart on the wall in like a nice conference room or something. And then also with the local power, depending on your need for backup, it could increase the cost if you had to have a UPS at each location. As you can imagine, if just look at one splitter, 32 ONTs on there, it's 32 separate UPS locations, so that could get kind of expensive. And then increased risk of disconnection under a desk. True story, as I mentioned, I have a long history in PON, and early on in the early enterprise days of PON, did a large installation in a high-rise in New York, and at the time, there was not really remote power options for optical LAN, and at each cubicle location, they had a quad outlet under the desk, and that outlet contained a spot for the monitor, spot for their PC. It had a spot for a lamp with their phone charger on it, and then the fourth outlet was reserved for the ONT that served either one or two cubicle locations. And we installed this in March, and from March to November, the system operated flawlessly. And then all of a sudden, in December, we started having issues out in the cubes. And I'm from Florida, so forgive my insensitivity, but I guess it's drafty in New York in November, and several people were bringing in under the desk heaters, and they knew where all the plugs went except for the one that was going to the ONTs, and that was the one that typically was getting unplugged to plug in that under the desk heater. So that's what I talk about when I say sometimes the local AC power may not be the best choice. Next slide. This is a traditional rectifier power, and when we say that, it's typically closet-based. It's a rack or wall mount options. It's low voltage, considered class 2, covered under the NEC article 725. And what that states is you can have a maximum of 60 volts DC at 100 watts per wire pair. And the reason I say that it is possible utilizing 2 or more pair to increase your power to an end device, and there's some restrictions associated with that, but that possibility does exist. It provides for a centralized backup in one of two ways. It could be a UPS located in that MDF or IDF, or a centralized DC plant, which we're seeing quite a bit these days, utilizing a high voltage DC to the MDF or IDF, then being converted to usable power for the ONTs or end devices. As I mentioned, within that remote power, there's been some new advances, especially in the intelligent power. And what that provides, or what that means, is that you now have the ability with certain installations to remotely monitor the voltage or current being used at an endpoint, and And then if you remotely monitor fault status, so if there's a short or something like that on that power line, you can see what caused that fault. But the most important benefit that we see is the remote output reset. And what that means is we can actually turn off and reset an ONT or an end device remotely without going out to that device. We've probably all been on the phone with our cable company, having trouble with our cable or our internet, and they tell you over the phone, hold on just a minute while I reset that modem. And they do that, and it doesn't work. And the next thing they ask you to do is unplug that modem. And so this is your way of unplugging that modem without, rolling a truck out there. It's really important in a hospitality, and some of the examples that Steve showed, if you have this installed in a closet in a hotel room, you can remotely reset these devices without disturbing the guest. We see it a lot in manufacturing where the ONTs are mounted up high in locations with access points or deep into a manufacturing or logistics facility where you have to get a lift or something like that to go up and reset that end device. And I think they had a golf course example, perfect for that as well. And again, just like the others, it can be centrally backed up either a UPS or a central high voltage DC. Here's an example of a typical distribution. This particular example is part of a combined connectivity solution that I'll get into in the next slide. But basically with this one, this remote power has a built-in splitter as well. So what that allows you to do is take your ports from your ONT or your OLT out to the combined splitter / power supply, and then from there, wherever those are located, take your splitter feed and your power out to your ONT and then extend onto your end device. Next slide. This is an example of that combined connectivity solution. And you see these are becoming more common. The input power is variable. It could be AC plug and go or a high voltage DC input on the back on the business side. And then on the output, you have your 32 or 16 or 8 100-watt 56-volt DC outputs, but also integrated splitter within there. So you get your power and your splitter all combined in a 2RU unit there. So it saves rack space and at the same time gives you those that power monitoring, onboard push buttons for a local reset of a circuit, and then your other controls and monitoring abilities. Next slide. I talked a little bit about the high voltage DC. I just want to dive into that just a little bit more. We're seeing more and more buildings having a DC grid, if you will, so a centralized DC plant. I think Steve showed that also in the stadium example, to where they have a high voltage DC, and that feeds the MDFs with 192 volts plus. There's a lot of systems that some you see on the screen that can accept either an AC or a high voltage DC equivalent into their systems, and what that allows for is rather than having UPSs in every IDF or splitter power supply location, you can have a centralized backed up DC plant that feeds all of your closets. Next slide, please. And I want to talk a little bit about power accessories. These are kind of something that somewhat new and needed in the industry, I think. The first thing you see down at the bottom is a power patch panel. We think this is a better way of doing an installation when you're doing a fiber power installation that allows the electrician or cabling contractor to pre-terminate your fiber as well as your power on the back side of a patch panel, and then allow you to come in later and patch your power from the front of that patch panel down to your remote power device. And also the use of patch cords, power patch cords, and we like this for flexibility of patching to different. You can patch different groups to different splitter power supplies. But we also like the ferrule tipped ends, and whether you use a patch cord or not, if you're just connecting straight, we still recommend the use of the ferrule tipped ends. It's a more secure connection in your typical Phoenix or whatever screw type connection that you have for for the patch cord or at the end of the ONT, but it also prevents that wire fraying that you see when you screw down a wire on screw down the screw on a bare wire. Next slide. I'm going to jump in just a little. I get a lot of questions on power calculations, so I just thought I'd throw this in here. Our website and many of the websites of the Passive Optical LAN members have cable distance calculators. And for on the PON side of things, you need to know is that most typical ONTs that operate at a nominal 48 volts DC, we've found in our testing, and it's not all ONTs, but most operate at best at 51 volts DC and above. So the things that you need to know is the ONT power load. What's the ONT itself take just to run with no POE load? Then you need to know the POE load and the cable distance from the source to the end device. And when you have all of that, and kind of in the example below, where you have your ONT power, your access point power, a VoIP phone, the 39 watts, you divide that by your source power. And you can see in this example, we have 0.7 amps. So that allows you, that gets you to where you can have all the information you need to input in a calculator such as ours. But what I want you to see in that particular example, at a half an amp at 1,500 feet on a 14 gauge cable, we're still at 52.21 volts DC. So, you know, that's within that 51 volts DC that we recommend. But the important part about that is we see, you know, across the gamut of starting voltages. Some people, you know, have 48 volt DC power supplies and it goes up to 60. That starting voltage matters, and the for the example, you see as that starting voltage goes down, the current would go up. So that would decrease the distance that you can go and stay within the requirements. So, and another question I was getting, just a note I put down here at the bottom, if you can reuse existing Cat 5e or Cat 6 cabling for your power. And you absolutely can, but the thing that you need to remember when you do so, that if you use 2 pair for your positive and 2 pair for your negative, you're still only getting, on average, an 18 gauge wire equivalent. And I believe, next slide, I think that wraps it up for me.
Yeah, it does. Thank you very much, Jeremy. I think that was fantastic. And I wanted to thank each and every one of the panelists here today. I mean, we clearly had some great expertise here, and really appreciate you and your company stepping up to you know, helping educate the market on these critical features and best practices. You know, I did want to put a plug in here for the Association for Passive Optical LAN overall. You know, we are always looking for new members, and are also always here to be an educational resource and a evangelist for this market. So if you are interested in joining a set of companies that you know, are the who's who of this market right now, I would highly appreciate and recommend that you get a hold of us, and just go to www.apolanglobal.org, right? And we'd love to chat with you and see how we can help and find a place for you in the industry. So with that said, you know that we're at the top of the hour. I will ask one quick question, because I did see a constant theme across this, and I think this is probably more appropriate for you, Ron, but I'm sure the others can chime in as well. There's a lot of questions coming in around typical loss budget considerations. Are there some elements of that that you might want to highlight for us, Ron, and then we can see if anyone else wants to chime in on that?
Yeah, so I mentioned before that the Splice on connector is the lowest. It has the lowest loss at 0.35. A typical Splice has 0.1, and then when we start looking at our splitters, you know, one split you would think that's 30 dB, but there's other components within that splitter that adds a little bit more loss. So when we're looking at a 32 port splitter, 1 to 32, that's about 17.5 dB. As opposed to like a 1x4, which is 7.3. These are all published from the manufacturers of the components, and if anybody wants more input on that, I can certainly answer via email.
All right, great, thank you. And anyone else want to add to that? Well, you know, I think we had a lot of great information shared today, and certainly I want to be respectful of folks' time with regard to the hour planned overall. So as I mentioned at the beginning of this is one of 5 existing webinars that we've been producing over the last 5 months here at Apple LAN. Our next one will be in mid-December. We'll be focused on that intersection of passive optical LAN and 5G. So a pretty exciting topic and timely, I believe, as well. So look forward for information on that coming up on the website soon. And we'll also be doing obviously some outreach to you all as well. But thank you very much. I will also say that this event has been recorded. Our intent is actually to not only post the event recording here soon, but we'll try and PDF these slides and make sure that they're easy for a quick accessibility for you as well. And we'll send a follow-up note to the folks who are on this this call, just letting you know what those links are on the Apple LAN website. Okay. One last time, thank you, Jeremy, thank you, Rich, thank you, Steve, and Ron for being part of this whole mix and pulling it all together. And we will look forward to seeing you next time.